Does your statistics team keep telling you that relative EC50s are more robust than absolute EC50s? That is indeed the case, but is it really true biologically? In this video, we will discuss the cases where it is best to use absolute EC50 and the cases where it is best to use relative EC50, not only from a statistical point of view, but also from a biological point of view. This video follows another one I've made recently on whether to use raw data or log transform data to calculate EC50s, either absolute or relative. I will put the link to that video either here or below in the comments bar. There are quite a lot of good references on how to calculate relative or absolute EC50s, so I will not go in much detail in this video. I put here two good references. The first one is from GraphPad. So of course, GraphPad is a software that is very often used to calculate relative or absolute EC50s. And also a literature reference where again the formulas are described as well as all the conditions that need to be met to calculate appropriately either relative or absolute EC50s. To really understand the cases where it is best to use absolute EC50s or relative EC50s, it is first important to remember shortly how both are calculated. So first on the absolute EC50, I remind you that each antiviral assay should contain a VC or virus control with cells plus virus but without inhibitor, and this condition represents no inhibition of viral replication, as well as a CC or cell control with cells only, no virus, no inhibitor, and this condition represents full inhibition of viral replication. From this, calculating the absolute percentage inhibition, and thus the absolute EC50, uses directly the values for the VC and the CC wells as follows. So the parameter that you're measuring in the CC wells represents 100% inhibition, and the parameter you're measuring in the VC wells represents 0% inhibition. And then the absolute percentage inhibition is calculated as follows. It is 100 times the ratio parameter VC minus parameter sample divided by parameter VC minus parameter CC. You can also calculate, and it is often done like that, using the compound dilution series and a 4PL nonlinear regression model. You then need to fix the bottom to the parameter VC and the top to the parameter CC. This can be done easily in GraphPad Prism. As a reminder, absolute EC50s can only be accurately measured and estimated when the parameters that you are measuring in the VC wells as well as in the CC wells are stable. And in the compound dilution series in the 4PL model, at least 2 points are projected to be above the 50% value, and 2 points are projected to be under the 50% value. Now moving to the relative EC50. Calculating a relative percent inhibition does not use at all the values for the VC and the CC wells. Instead, it only uses the compound dilution series as follows. So the parameter you're measuring at the highest compound concentration represents 100% inhibition, and the parameter you're measuring at the lowest compound concentration represents 0% inhibition. And thus, the formula becomes the following. So the percentage relative inhibition is 100 times the ratio parameter at the highest compound concentration minus parameter in your sample, divided by parameter at the highest compound concentration minus parameter at the lowest compound concentration. You can also, and it is very often done like this, fit the compound dilution series to a 4PL nonlinear regression model without any constraints. This can, for instance, be very easily done in GraphPad Prism. As a reminder, it is only reliable to calculate a relative EC50 when the parameter you are measuring for the two highest compound concentrations are at the top asymptote, and the parameter you're measuring for the two lowest compound concentration are at the bottom asymptote. And the EC50 estimate shows less than 5% variability. Here is a graphical representation to help understand potential differences between absolute and relative EC50s. So on the y-axis, the viral replication in relative units is shown, and on the x-axis, the compound concentration. The actual compound dilution series is shown in red. Moving first to the absolute EC50, please look at the green text boxes. So the VC wells represent 0% absolute inhibition, and the CC wells represent 100% absolute inhibition. And the 50% absolute inhibition, and thus the absolute EC50, will be defined in the middle of these two values. Now moving to the relative EC50, please look at the red text boxes and lines. You will appreciate that this compound dilution series never reaches the CC values and the 100% absolute inhibition. It is probably a partial inhibitor, but to calculate the relative EC50, this does not matter. So the relative EC50 is only calculated by the bottom and the top asymptotes in the dilution series. And so in that particular example, the relative EC50 is actually lower than the absolute EC50. There can actually be a lot of different cases observed, and there are also cases where even the VC level, so the 0% absolute inhibition, is not reached, or is even higher than that. So further impacting the relative EC50. Thus, it is very important to understand whether you are looking at relative or absolute EC50s. If you can calculate reliably both absolute and relative EC50s, which one should you choose? Actually, my first advice is that if you cannot reliably calculate one or the other, please repeat the experiment, possibly with a different compound concentration range, so that you can reliably calculate both. Now, as I told you before, often the statistics team prefer the relative EC50s and then using a 4PL nonlinear regression model without constraints. And because it's without constraints, it is statistically more reliable. However, in my opinion, this has a real impact biologically, as you have seen. So if you can, go with the absolute EC50. It will give you a more accurate view on the true level of viral replication. It is important if an inhibitor doesn't reach the CC levels. If you need to go with relative EC50, so you don't have the option to go with absolute, you cannot really repeat the experiment, then at least report the maximum percent inhibition as well, next to the relative EC50. That will allow you to detect partial antagonists. Another point, we now discuss a lot about EC50, but EC50 only represents 50% inhibition. Most of the time, you don't want to go for 50% inhibition. You want to go for full inhibition, and thus prefer EC90 over EC50, or even EC95. So absolute EC90 or absolute EC95. Do check whatever the maximum percent inhibition across the dilution series. So that will allow you to detect if there are partial antagonists. And also check the percent inhibition at the highest compound concentration. Sometimes there are strange curves and kind of hook effects. which you may not want to select down the line. As a reminder, EC90 is very often the value used in human dose projections, not EC50. If you really like a compound class, but this one never reaches CC or VC levels, so absolute 100% inhibition or absolute 0% inhibition, it is very important that you understand why. Don't just leave the discussion for later and really understand why. Why biologically that might be the case. And maybe it's a good thing, maybe it's a bad thing, but at least you need to know. Of course, do take into account the mechanism of action of the compound class you're studying versus the parameter measured in the assay. So, for instance, a viral egress inhibitor will never inhibit the first replication cycle by definition, and thus it will never reach CC levels in an assay measuring the percentage of infected cells, because there will always be this first replication cycle. In that case, it might be perfectly fine that the 100% inhibition is not reached. But anyhow, again, please understand why. And another very important point that is barely ever done, and even I need to really, really pay attention to that one, is to report the exact analysis method you use in the material and method section of your scientific publication. So, both absolute versus relative, EC50 versus EC90, and then again, as discussed in the previous video, log transformed or raw data. All right, we come at the end of this short video. I hope it was useful to explain or remind you of the differences between relative and absolute EC50s, and that you will now really pay attention at what you're exactly looking. I'm also very curious if you have any other advice compared to the one I've given you. Do you prefer relative EC50s, and for which reason biologically? If that's the case, please leave a comment below. I'm sure we can have a lot of discussion, especially with statistics team. Bye bye.